If you go there, then you can find a README that gives you instructions on how you could submit a talk, and how you could give a talk. There's an issues section where you can do all of that and upvote. So please go there if you'd like to participate. So with that, Danny, if you want to come up, we'll get started.
Unlock my computer here. Can everybody hear me? Can you not hear me? Mm-hmm. Of course, it's not set up right. Am I sharing on the Adobe Connect? Oh, yeah. I'm not seeing the share. I'm not seeing the share button on here. Refresh that page. I'm not seeing the share button though.
Oh, you logged in twice. Here, I'll make your second good presenter. Now you can share.
Is it sharing now? A couple times. Keep clicking it. Yeah, it's not allowing me to share.
Click your other Danny. Now click share. Drop the drop list. Share my streams. Okay, just close it and close both your meeting tabs, close everything out, and rejoin them.
You want me to just close the tab?
Yeah. And your other one. You're in there twice. You have another meeting open anywhere? Yep, close that guy. You have anything else open?
I don't think so.
Now you're gone.
Oh,
No, you need to
crap. My...
Make you a presenter. Now share your screen. Are you running your plugin? Very good. Now you're sharing.
Okay. So like he said, my name is Danny Fenstermaker. I am a front-end engineer at Jive Communications. Been there a few months. Shameless plug, we are hiring. So any Angular devs looking to start a new position. My talk today is on Angular, ES6, and Webpack. This is going to be more a get started with Webpack. Not so much focusing on ES6, but kind of getting scaffolding ready to be able to use ES6 in your bundling and build with Angular. What is from their own website? What is Webpack? Webpack is a module bundler. Webpack takes modules with dependencies and generates static assets representing those modules. Why would we want to do this? It allows us to bundle all of our JavaScript, images, assets, fonts, you name it, into one file. It gives faster download times for our users, gains some modularity in our file structure, and ultimately a speedy development process, hopefully. When can we start using it? Now. Webpack has proven itself to be a pretty viable option for bundling. I would say one of the top contenders for bundling at the moment. It understands the AMD, CommonJS, and ES6 module systems. It allows you to work in all three of these module systems at the same time or focus on one. So for those coming over from Require.js, it understands the AMD module system, Browserify, understands CommonJS, so on and so forth. So getting started, this is kind of what I wanted to focus on today, is just showing everybody how to really get started with Webpack from a very basic level, like gulp and grunt and other JavaScript tooling. Webpack uses a config file. It's named webpack.config.js. It's ultimately an object that is exported via the CommonJS module system type. So it's module, exports modules, exporting an object. The first argument or property in that object for Webpack is an entry object. The entry object is where each property of the entry object is a starting point for Webpack to traverse, to start traversing. This can be one-to-many properties inside of here, and each property can be a single string argument or an array of strings to traverse. In this case, we're calling index property and saying to start at the index.js file in our application. The next thing would be the output. It needs to know where to stick that index, traverse the thing it just traversed, all those files, that bundle. It needs to know where to stick that. And in this case, we're giving it the path of a build folder and file name. Webpack gives us an argument available to us, a param called name, that we can give the file name, which corresponds to the previous entry property of index. It also gives you a hash argument in here that you can also put in the name of the file if need be. Let's see. With just that alone, we now have the ability to traverse all of our files. Webpack now knows how to traverse your entire file system and ultimately bundle it, assuming that we have loaders. This, to me, is where the power of Webpack resides. Simply put, a loader is a function that is run against a specific file type. It runs functionality on that file type and passes through the contents post functionality being ran. There are a lot of different types of loaders. Pretty much everything that you do in Require and Browserify and these type of things is represented by a loader. Some of the most common loaders are bundling, different file types, linting, shimming, and transpiling. Loaders are installed via npm and live in the node modules folder. They are used in the Webpack config file in an array under a property called module.loaders. Each loader is an object in the array with three main properties, the first of which being test, and this is just a regex expression telling it which type of files, be it one or many types of different files, to run the loader against. Next is exclude or include, depending on what your preference is. This basically tells it, as it's traversing your file system, if you ask for something like Angular or Lodash or something of this type, you don't want it running your loaders on that particular file type. You don't want it linting or trying to annotate or something of that nature on outside libraries. So you tell it here, either exclude anything under these folders, or include anything under said folders. Next is the loader itself. It's just a string argument. In this case, I'm using Babel, which corresponds inside of the node modules folder to a loader called Babel-loader. And Webpack knows how to, in this case, I'm just calling it Babel. It knows to append the dash loader and traverse the node modules folder for that name. One of the interesting things here is that loaders can be stacked on top of each other. So if you look at the bottom, there's ng annotates, ESLint, and Babel all being used. So each time you request a file of type JavaScript, it's going to get out of here. It's going to run Babel, and side note, loaders are ran right to left and separated by an exclamation point. So in this case, it will run Babel and then ESLint and then ng annotate before passing it to be bundled and written to file. So for Angular, since Angular does not adhere to any module system itself, it has to be essentially exported off of the global space. And this can be done, you can either, there's a lot of different ways to handle this. I chose to use a loader just because it makes sense to me. Some people wrap it in a module and use an AMD or CommonJS style around it. In this case, I'm just saying, if you come across file of type AngularJS, then go ahead and export that from the global space into my application. And then that way in each file I can require Angular and I'm actually getting Angular. So this is my typical loader setup here. I just thought I would include that to give everybody kind of a look. This is doing Sass, HTML, JavaScript, Angular. This would be ES6 in this case using Babel. All that would need to be done on this is to go and download a couple of loaders from NPM, and it's pretty much up and running. Quick mention. So there's another property in the Webpack config called resolve. Under this is the argument there, extensions. In here, you can put the different file types that you may be dealing with. So in this case, .js. You can put .scss for Sass, .html, what have you. And this allows you to not put a specific file type on each of your requires. And it will automatically check against this array of typical file types. And if it matches any of these, it will go ahead and apply that. This is in case you're using something like CoffeeScript or Jade or something of that nature and decide 6 months from now to switch to a different transpiler. You don't have to go through each of your files and update it from CoffeeScript to JavaScript to HTML, what have you. And it's kind of a convenience. Module directories, this tells it which module, which folders it's okay to traverse. And so it kind of gives it almost an alias, and it knows these are the folders it needs to go into to look for your files. So aliases, another thing, another convenience. If you're going to be requiring something quite often that has a relative path, like your main module in Angular, you may want to use an alias so that you're not tightly coupled to relative paths throughout your entire application. And if that file ever moves, you're broken. In here, you can tell it if anybody asks for module, use this module.js file and alias however many aliases you want throughout there. Kind of nice. So now what? Now we have everything set up. We have entry, output, all of our loaders set up. Now it's time to go ahead and just bundle. We can install via npm. I install in the global space Webpack. And I just go to the root of my application and run Webpack. And that's it. It will now have an index.js file under the build folder. And it's pretty much ready to go at that point. You can put an argument in the command line for -w or add a watch property to your actual Webpack config and set that to true, and it will continue to watch your files. And if anything ever changes, rebundle them and be off and running. In its package, it will now be in, like I said, the build folder there, ready to go. Yeah, you can open it with any server at that point. However, Webpack has a dev server available to it, and so I wanted to go ahead and talk about that. So, like Webpack config, Webpack, we go ahead and install via npm. I call my Webpack server webpack.dev.server.js just to relate it to my dev environment, as it's not supposed to be used in prod. So, just like to make that very clear in my application. So once we have that installed, we can go ahead and pull in the server, Webpack Dev Server there, the config, our Webpack config that we just created, and Webpack itself. Next thing we want to do, for me, since we're in a dev environment, I go ahead and at runtime, I switch the Webpack config and add in the watch variable at this point, because I know I'm going to be in my dev environment. I know I'm going to be wanting to watch all files. Next is to compile the Webpack config via Webpack, and then go ahead and pass that compiler to a new version of the server. And then the second parameter there after compiler is a list of options, and they have things like hot swap and what have you. There's a link there for anybody interested in checking out the options for Webpack Dev Server. After that, tell it the port, where it's running from, and it's done. Yeah, and just go ahead and node, run this via node, and it's now running on port 3002. So this is one of the interesting things. You can go ahead and point, you're going to have to actually point your index.html file at the Webpack Dev Server. There's a virtual file that's being created on port 3002, and it's going to connect your index.html to this. This is for live reload out of the box. It is ready to go with this. Another really interesting thing here is that the index.js file is also virtual, and I mentioned this in the next thing here. So under the Webpack Dev Server, your bundle is actually never written to file. So once it's running, there's no way to go in and actually look at a file and see if it was built correctly. Everything is in memory, and this is done for speed. It allows them to quickly hot swap out any changes that are being made while it's watching. And so also that, let's see, where's that? Also, you see here that the index.js is not, it's not pointing at build/index.js, and that's because the file does not live in build/index.js. It actually lives in a virtual environment where Webpack Dev Server knows it exists, and so as long as you put index.js there, it can reference that virtual file. Yeah, it should not be used for prod. Yeah, because they're virtual files, they do not need a full file path. So this is a pretty cool feature of Webpack. Sometimes the Webpack gets really slow in its bundling, and the Webpack team guy built this tool that allows you to output a JSON file that is your Webpack build, upload it to this analyzer, and it essentially builds a D3 chart of all the nodes in your application. And can show you, you can click on each node and it can kind of show you some of the slow points, and it shows you to the right there where your choke points are, where it's slow, where it's not being cached, what your optimizations can be, and it gives you a really good indication as to where these optimizations can be made. It even points you to some plugins to tell you like, hey, you need to go use this. That can be done via the webpack.github.io/analyze, and then on the page, it's not very clear, but you can do this webpack-profile-json, output that to a JSON file, upload that to that URL there, and it will take care of the rest. It'll show you all of your mistakes. So last but not least, last thing we need to do here is bundle. So I use the Webpack Dev Server for my dev environment. I use Gulp for production environment. So it makes a clear indication that I'm using, makes a clear distinction between the two environments, and I can set variables in the dev server that are different than the Gulp build and build for prod versus build for dev. So assuming you have Gulp installed, you would just use Gulp Webpack. Go ahead and create a Gulp config file. In there, that's the entire, it's pretty much my entire Gulp prod build right there, with the exception of a couple of Gulp modules, ngmin, possibly annotate, depending on the situation there. So literally, what, 10 lines. So some things worth mentioning. The Commons Chunk plugin is a nice little plugin. It allows you to separate out commonly used modules such as Angular, Lodash, things like this that are being required everywhere in your app, and separate them into another file that can be named and hashed and cached ultimately by your users, so that the next time you go to push out a version, the hash won't have changed in your common files, and users won't have to download Angular and Lodash and all these things again. It's kind of nice for dev environment as well, just to have everything separated and only be dealing with re-downloading your things that you just changed every time. Also worth mentioning is HTML Webpack, which is dynamically build your index.html. So you can give it a template, and the plugin takes that template and takes the server and knows what files are going to be coming out of there. So it automatically appends those dependencies or sources in all of your bundles for you, and your index.html file is already ready to go. You don't have to worry about knowing the name of your bundles and all of these things. And it's kind of convenient also for going into prod. It takes environment variables, and you can tell it in prod, I'm going to need you to point at my build folder or my dist folder. But in my dev environment, just use the server bundle there. Sorry, and this ran a little faster than I thought. There's my info. Any questions? No? Go ahead. Yes. Absolutely. I haven't done it with the dev server so much as I just have npm test on there, and it's running Webpack and all that stuff. In fact, I have an application that I built as a sample app that I'll release to everybody when I'm done here, put it in the thing, and it has a Webpack build, a tiny application that is using Karma tests and Webpack and Jasmine and all that fun stuff. So, yeah. Any other questions? Cool, thanks.
Okay, while Derek's getting set up, feel free to go back. There's more food, and especially forks, so feel free to go back there. Derek was actually our first speaker at the meetup more than a year ago to kick it off, so he's back for more. So it's going to be good.
Hi guys, everybody hear me all right? So I'm Derek Stobbe. I am a front-end developer at Workfront. So I've been working for working on Workfront's front end for about 3 years now, and about a year and a half ago, we made the switch to Angular. I love Angular. It speaks to me. Ever since we decided to go with it, I kind of took off running, and it's great. But I started to get a little worried about the ability. So we're kind of stuck on Angular 1.2 something, because for IE8 support reasons. But even looking forward to 1.4 and those things, I started to worry about whether the Angular of the future could handle our requirements and the speed that we wanted to see out of our applications. It was kind of such a big deal to me that when a performance critical feature came up for a rewrite, I started thinking about React. And that did not go over well. I think one of our front-end architects threatened me with a baseball bat. But I went to ngconf, and one of the talks was Angular plus React equals speed. And I was like, ha, you can do it. This does happen. And so I watched, I don't know if you saw that, but he demonstrated this application using React for the rendering core instead of Angular directives, and it was so fast. And then at the end of the talk, there's like brief 5 minutes about how Angular 2 was even faster. I was like, wait, I want to know more about that. So I realized what I didn't want to use React. I wanted better performance. And so I started thinking, well, what can I take out of that with Angular 1.x and what React is giving us? What can I get from that will give us performance wins? The answer to that is Flux. And as we'll break it down more in a minute, but Flux is kind of a mental model. It's a architectural pattern that has been evangelized by some really smart people over at Facebook. They started seeing some performance problems and some scalability problems with one of their features, specifically with chat. There's a great video that you can find by Jing Chen. She talks about the problems they were having where you have your chat, your little chat window that you're talking to somebody, and then you have your chat messages, and then you got the jewel up there that says how many unread messages you have. And she said as they were trying to grow this out and add new features on, they were seeing problems like the chat jewel would tell you that you had an unread message, and then you'd open up and there wouldn't be anything. She said, everybody's seen this at some point, and we would fix it for one specific use case, and then it would pop up again somewhere else. And it was just a problem that we were trying to store our data in too many places. So, as you're sending messages to a friend, they're receiving that message, and if they're not at their computer, it's incrementing here, and then it's incrementing otherwhere, but what if they happen to read that and the code doesn't? So she said it was a big mess. And Flux, the Flux pattern with React is one of the ways that they went about solving this. So I'll give you a spoiler alert. Angular plus Flux is awesome. So I started thinking, what can I do? And this is the Flux pattern. This is kind of the breakdown of it, and we'll break it down more in a minute. But I started thinking about this, like it says, React views here, and that's kind of we're using Angular, we're not using React. So, but what can I take away from this? What can I glean that will let me build faster Angular apps? Angular 1.x, one of its claims to fame, I think, was its two-way data binding, right? Like, oh my gosh, you can make data happen, and it'll change in your views, and then you can change it in the views, and it'll change back. And I think that's one of the reasons that Angular got so popular. But 5 years down the road, we're like, maybe that's really hard to reason about. I mean, I changed something here, and something else changes because of that. Something else changes. Everybody's gotten the infinite digest loop error, right? At least once. Happening because our data is hard to reason about. We don't know what this change is going to change down the road, and that might even change our original data, and that's a big problem. So Flux is meant to solve that. It's supposed to be a one-way, a unidirectional flow, because one of the things that Facebook was saying, these Facebook engineers coming up with this pattern, they said that the developer's mental model of the code is at least as important as the code itself. And I think that bears repeating. The developer's mental model of the code is at least as important as the code itself. So if I, as a developer, cannot look at my code, look at an application and say, there's a break here, and I know where that has happened, then I've failed at this principle, right? If I cannot easily determine the flow of information, of data, through my application, then the model, my mental model is too complex. I can't keep it all in my mind. I have to jump around through files, and that's not gonna, it increases development time, it increases defects, things like that. So again, here it is. And so looking at this, my question was, what do we have from Angular 1.x? Because I would like to say we're gonna migrate to Angular 2 as soon as that comes out. And actually, Angular 2 is taking a lot of these same principles. They're saying, okay, so the bidirectional data binding, maybe not such a good idea. It's more of a unidirectional flow. They're not calling it Flux, but they're saying these are really good ideas. And so I want to be ready. So it starts out with the view, right? And so with the view, Facebook is using React. Lots of people are using React. That's kind of a big deal. But we have Angular directives. And it's a little bit of a change because the directive communicates through data stores. So the directive doesn't hold its own global state, right? One of the things that they said solved a lot of their problems was not duplicating data, right? Don't duplicate it. Just have a central source of truth and go from that. So I have written directives. I have written many directives that will go and kind of fetch their own data and manage their own state and all of that stuff. And this is kind of a slap on the wrist saying, no, bad, don't do that. So our Angular directives are responsible for user input and managing its own state, right? So that might be managing animations or anything that is specific to that directive, to that piece of the UI itself, and not to the overall, right? And so based on user interactions, these actions come through, and we have these services or factories. And I'm going to go kind of fast. We don't have a lot of time left. But we have these services or factories, and I'll demonstrate all of this working together in a production environment in a little bit. But we work with these every day, right? Anytime you write Angular, you write a service or you write a factory that handles interactions through APIs and receiving data and things like that. So under the Flux model, our services and our factories dispatch actions, and they're responsible for asynchronous communication. So what are actions? Actions are just bits of data, right? They're just packages saying that something has happened in our application. We received messages, or somebody read this message, or we have a new notification, that kind of thing. So we're just passing data around. And again, it's going one direction. So it's easy to reason about. So I know that when if I'm back here at my view and I click load more, right? It's going to send out an action saying, hey, the user wants to load more messages. And I know exactly where that's going to go. It's going to go to my API utils. And Angular gives us things like $resource and $HTTP to interact with our server that goes out and it'll grab, in our example, it'll go grab more messages. That comes back in, and it's just a payload of data, right? So you can see we received messages, and it'll give us the message in a data object that we can use that comes back to the dispatcher. And this is kind of the traffic cop of the whole thing, right? So the idea of Flux is that at any given point, there's only one kind of loop of data happening, and you can't, it'll throw an error, it'll reject an attempt to alter data that's not in the main flow, right? So you can't go out and start another loop here while you're in the middle of one. And that forces you to think about things in kind of a unidirectional flow, right? So if everything's coming down, I have to, when data comes back from the server, it doesn't go to the directive. It doesn't go to a service or a factory. It comes back through the dispatcher and says, hey, I'm ready to re-enter the system. When it's my turn, can you let everybody know? So the dispatcher receives those actions and those from the action creators and notifies stores. And so a store, I can show you an example of that in just a minute, but it's just that. It's just a store of data that is read-only. So my view, in order to get all the data from a store, and so a store might be a list of messages, it might be notifications, or it might be whatever else. All it has to do is ask. And it's idempotent, so anytime that it asks between changes, it'll get the same data back, and it's read-only, so I don't have to worry about somebody else changing it out from underneath me. It doesn't really matter where that data is coming from as long as it comes back in through the dispatcher, right? As long as it goes through the cycle. So the store receives actions from the dispatcher, and tells interested views, hey, something has changed. And that kind of brings us back in this full loop. So that was a really whirlwind introduction. So let's look at some code. Actually, before I jump over, any questions? Feel free to interrupt me at any point with questions or clarifications. Okay, so I have a confession to make that my coworker built this, and while he was out of town, I was like, I want to see how the Flux pattern works with this. So I rewrote his code. Oops. And I thought, you know, I'm going to get in here and I'm going to start working on this so that I can see how the Flux pattern works, so that I can see whether the next time I want to start a project, whether I want to use Flux or not. And I was surprised, in about a day, I was 80% complete. It was really, really fast to take what I had written, or what he had written in Angular, and convert it to use Flux. Again, because Flux is not a library, right? The only boilerplate that we have is the dispatcher that the Facebook engineers wrote. So it's just a change in the way of thinking. So we have this notification page, and it's mirrored here. And so when Jingchen was talking about her problems with the chat app, it was kind of resonating with me. I was like, hey, we're facing those same problems, because, you know, I'll come over here and I'll mark one of those red, and it wouldn't update here. Ooh, they added a fancy animation. Nice. Or, you know, same thing. If I come over here and I mark them all as seen, I need them to mark as seen across the application. We were coming into some of those same kind of things. So in this case, there's, jumping back to this. So the views, we have two separate, and the way that we've architected our application, we have a lot of different little Angular apps instead of one big one. And that led to a lot of the complexity in using this was just dealing with synchronizing data across two Angular apps, which is not something that happens in everyday development, right? So we have two different sets of views. One is this notification pane here, and the other is this notification pop-up that take similar interactions, right? From either place, we can acknowledge a notification, we can visit the notification page, we can mark them all as read. So we have the same set of actions shared between them that all come through the dispatcher, and then we have two stores. We have the notification store and then the unread notification store, because I only want to see unread messages up here. And let's go into the code. This is going to be a little small, blow it up in a second. We got a lot of files open. So I have my notification store, right? And so it's just a factory that, we used event emitters. That was one of the pieces of complexity that we had to deal with for dealing between two different Angular applications. So we used event emitter, but you could use just like a new scope, so like root scope.new, and then broadcast and emit from that. Angular gives you all the tools that you need, again, to handle this. So this store, all it does is, you know, it provides an API to get all of my notifications, or to return if I'm pending, so that I can show when I'm in a loading state, things like that. And then it registers itself with the dispatcher, which again is the traffic cop, and it says for each action type, and it's easy to confuse an action creator, which is a function or a service or whatever, with an action type, with an action. An action, again, is just data, right? It's just a JavaScript object, or a class, or however you represent your data. And those get, the dispatcher gets notified of those through these notification action types. So all my store is saying is, when I receive notifications, I want to normalize them, I want to format them however I want, and then I want to tell interested stores that I've changed. So my interested stores, in the case of this application, my interested views are this popover and this list, right? So when the store changes, when data comes back in through the dispatcher, it just says, hey, I've changed, if anyone cares, right? And so you You could again use event emitter. You could use your own dispatcher, whatever you have. You can use a scope, a new scope with emit and broadcast. So it says, I've changed. Anyone that cares, here's my list. And then going down to the directive, we are not that one. Yeah. So in my directive, in my view, I'm just listening to that store. And when that store says I've changed, I just update my list of notifications to say, get the unread messages from my unread message store. The reason that I preferred this, the reason this has worked better for me rather than just a watch, is because I, as a developer, control when my store notifies of changes, right? A watch will fire at least once per digest cycle, and you can't control that. It'll happen no matter what. It doesn't matter if your code triggered the digest cycle. It doesn't matter if third-party code or if internal Angular code triggered the digest cycle. It'll fire at least once. And so you can get a lot of thrashing. You can get a lot of overhead, especially if for some reason my get unread function here was expensive to call, right? So by putting the change notification in the hands of the data store itself, I can control that to say only when I get new messages do I notify of changes, which reduces a lot of that complexity. I know exactly when that's happening, and I know exactly what's happening as a result of that, just because anything that is interested in that is going to be listening to the data store. So when that happens, it just updates its list of notifications, and it says if I'm pending, then just show our little spinner, a little loading spinner, right? And so to go back to this, all that had happened is I came to the page and an action fired off, right? And so actions usually result from user interactions, but in this case it happened because the page loaded and I needed to load some default data. So it went out to an action creator, which was a service, saying, go get me my unread messages, or go get me all of my messages, depending on which page I'm on. So we went out to, I used $resource to go out to the server, get a list of notifications, come back to the action creator, which then the action creator, with a list of that data from the server, sent it through the dispatcher, said, hey, I've received a new, some new amount of data or some new data here, and that came through the store. So the store was listening again to the dispatcher. We can go back over there for that receive notifications, which happened when the data came back asynchronously from the server. My service fired that receive notifications dispatch. The store listened to it and said, okay, now I'm going to normalize it, and I'm going to tell anybody that's interested that I've updated. And that brings us back full circle with our directive, with our view. And so because of this, it was there. Some bugs have popped up since then, and I think if you look at my notification page, you can see some of the conversation around those. Some bugs have popped up since then, use cases that we missed or edge cases, things like that. And every time it has been, I know exactly where that is. If the data is coming back but it's not being displayed properly, I can check in the formatter. I know that the store has gotten the data, and we have tests around that. So it's probably somewhere in the formatting that's breaking. Or, the data is not coming back at all. Let's check what's wrong with the store. So because of this unidirectional data flow that Flux provides or encourages you to adhere to, anytime there's a break, it's easy to think at what point that break has occurred, as opposed to some of the other Angular features that I've written where you get a lot of changes happening because of changes happening because of changes. You have to kind of follow that thread and say, okay, I wrote this and somebody else added this, which is changing that, and oh yeah, okay, so somebody else is breaking my data here. That doesn't happen anymore because first off, the store is read-only. Any view that's listening cannot mutate that data without going through an action, right? All they can do is read it. And because of that, as a side effect, everything else knows when a change has happened. So there's no breaking due to not understanding where in the process my data is being mutated. That is about all I have. Yeah, that's my last slide. Anybody have any questions? I know that was kind of fast. Yeah. Yeah, so the observer pattern is how your store would be implemented, right? Or possibly the store to view, or maybe even the dispatcher to store. Yeah, so it's just, it is the observer pattern. It's just defined in such a way that you know this is the flow that I'm taking through that pattern, right? Good question, yeah. Right, okay. So question is, where are we triggering digest? And that is happening here, in this section here, in the action creators, the web API utils. Let me see if I can find it really fast. There's kind of a lot of files. So it's not a root scope digest. I mean, it could be, right? If that's how you wanted to implement it, you could definitely do a root scope digest. In this case, we're using, well, so this toggle acknowledge, this acknowledge function, this acknowledge all, those all go out to the server via $resource. And so when that resolves, when that promise resolves, Angular is going to kick off a digest anyway, so, right? And so in response to that, in this then, in the then from $resource is where you notify the dispatcher, right? So you're kind of riding on the digest cycle that Angular has already initiated for you. But in another case, if you were triggering an action from a view, yeah, you might trigger that digest cycle just because, I mean, you'll need that anyway to update your data bindings and things like that, right? Did that answer your question? More or less. Good question. Anybody else? It could be. That's an interesting idea for caching that I hadn't thought of. It's in memory, so let me find that store. There it is. So this is a service, right, that resides in memory. And so when it comes back from the server, that just gets updated. In the assumption that we made for this feature, we would go out to the server on every page load and fetch new notifications. But if you wanted to, you could write your store a little more complex and say, get it and then cache it, and you can expire it at some point, but as long as you have anything in the cache, serve that instead of whatever else, right? And then in your dispatch switch here, when your dispatcher said I've received notification, you would just invalidate your local storage with the new data, right? And then you wouldn't have to call that server action until it was stale and you wanted to go again. So that's definitely one way to do it, but generally our implementation is that it's just in memory for the duration of the page load. Yeah. Yeah, so we have two stores, right? So we have one, this is all notifications, and this is unread notifications, right? And so we could have implemented them as two different stores that go out, that, two different sets of actions that go out and fetch data and feed them into the stores. But in practice, what we did was we made our unread notifications store wait for, and that's one of the pieces of boilerplate that Facebook has provided, is that you can have stores wait for other stores, and it's all synchronous, right? You're waiting synchronously for all those things to update, so you can guarantee the order that your stores are are triggered. But our unread notification store waits for our global notification store, and then you can see here that the get stuff just returns filtered for the unread, right? So it takes all the notifications and filters them down and only returns the unread ones. So I think that addresses your I'm kind of composing stores from other stores. But if I had some compelling reason, I could have had both of them have completely separate data flows, right? Any other questions? So this is gospel according to Derek at this point, right? So I have started evangelizing it and seen other teams kind of starting to pick this up. This is not something that has been mandated on high that we're going to use Flux, right? And again, it's not so much like you have to completely change your way of thinking. It's just, here's an architectural pattern that you might want to consider using everything that you're already doing. So at Workfront, no, new features don't have to be written this way, but I recommend it. And I know that other devs are kind of starting to see that same vision as well. So I can show you all of our action creators. And so it's just a factory with, it exposes an object full of functions, basically, right? So I have actions for the notification, and I have actions for the popover, basically just handling state. And so anywhere that those could come from, you know, you can use it that way. It just happened to work out for us that we expose them all through a factory. And in this case, like I said, I have two, one for handling the popover. This was a lack of clarity on my part because, like I said, because you have these data stores doesn't mean that you have to have a data store for every single piece of state, right? So my popover, it knows when it's open or closed, and nothing else really cares about that. And so the popover state could have been managed internally. It didn't really need a data store. But where that would be useful is if later down the line, somebody said, well, we want to like put a scrim over the whole page, or disable some function while the popover is open. At that point, a store would be useful because you're now dealing with state that multiple parts of the application need to deal with. Did that answer your question? Sorry, I kind of jumped on a tangent there. I don't remember who asked it. Yeah, great. Any other questions? Awesome. Well, thanks a lot, guys. Again, I really recommend looking into this as an architectural pattern because unidirectional data flow, even in a bidirectional environment like Angular, is becoming the way of the future. Like I said, Angular 2 is moving that way. React has moved that way. The more that you kind of embrace those patterns, the easier it's going to be to move forward. So thanks, everybody.
Hey, let's give Derek and Danny one more big round of applause. Yeah, that was great. I think, Matt, how many did you count came tonight? 119. So thanks to all of you for coming and making this possible. It's great to have a nice community like this. Feel free to linger and mingle. We have this room until 8 o'clock, and then there's still some food left if you'd like to take some home. Thanks.